Hello! Today we are going to be talking about FRQ number 2 on the 2023 AP Calculus test. This was just on the AB portion, not the BC portion. This is a graph and calculator question, so I'm going to show you how to use Desmos to answer this question. Alright, so let's get this party started and let's answer this FRQ. Okay, so let's answer this question now. This question was question number 2 on the AB portion. It is a graph and calculator question, and it focuses on particle motion. Okay, so the question states, Steven swims back and forth along a straight path in a 50-meter pool for 90 seconds. Steven's velocity is modeled by v of t, which is equal to 2.38 e to the power of negative 0.2 t times sine of pi over 56 times t, where t is measured in seconds and vt is measured in meters per second. Okay, this question is just like a regular particle motion question. There's going to be asking us, hey, is the particle speeding up, slowing down? When's it speeding direction? What's the total distance? That type of stuff. But it gives us a little bit more context that this is an actual person swimming in a pool. All right, so let's answer question A, part A. So part A is saying find all times t in the interval 0 is less than t, which is less than 90, at which Steven changes the direction. Give a reason for your answer. Okay, so right away, I know Steven changes direction when our velocity changes sign, or when our velocity is equal to 0 and it goes from positive to negative and negative to positive. So I'm going to state that, hey, v of t is equal to 0 and velocity changes signs. All right, so let's figure out when that happens. But first, we got to get that velocity function into Desmos. Okay, so we have v of t. So I'm going to put our v of x is equal to 2.38 e to the power of negative 0.202 times our variable, which is x. Make sure to bring that down, times sine of pi. I'm going to put pi, that drops that pi symbol, divided by 56 times x, and close that parenthesis. All right, so let's just analyze this graph on Desmos. So I'm going to zoom out a little bit so we can see the whole interval from 0 to 90. All right, click on it. It's going to say where our graph hits the x-axis. So at t is equal to 56, he is changing directions. Directions y. V of 56 is equal to 0, and v of t switches. Notice it is all positive values before it hits 56, and it's all negative values after it. So it switches from positive to negative. Let's check, is there any other time? That's all above the x-axis, then it hits 0, and then after that point, what happens? Oh, it's still negative, and it's negative when it hits 90. So that's our only point, or only time. All right, so that is part A, done. Let's go to part B. Find Steven's acceleration at t is equal to 60 seconds. Okay, so find the acceleration, show setup for your calculations, and indicate what units of measure. Then, is Steven's speeding up or slowing down at t is equal to 60 seconds? Give a reason for your answer. Okay, so immediately, I need to throw in acceleration. I need to get that into our paper. We need to talk about it. So should know in our head, hey, the derivative of velocity is equal to acceleration. So I'm going to show that. I'm just going to say, hey, v of t is equal to a of t. And then we're trying to figure out, hey, what is the acceleration at 60? So I'm going to say a of 60. I'm going to get that from our calculator. So let's pop up our thing, our Desmos insert section, and I'm going to put v prime with that little apostrophe, and I'm going to put 60 just directly in. Okay, and that spits out our answer. That would be negative 0.036. All right, and I think they're asking for our units of measure, okay? So V of t is meters per second. And we are taking the derivative of that. So we are adding an extra rate. So the meters is going to stay the same. And it's going to be over seconds. But in this case, it's going to be squared, seconds squared, because we're adding a rate. We're starting at meters per second. We're adding another rate. All right, and we have to show, is Steven speeding up or slowing down at 60 seconds? Okay, easiest way that I tell my students is saying, hey, figure out your velocity, figure out your acceleration. If they're the same sign, Steven's speeding up. If they're opposite signs, Steven is slowing down. So we know V prime of 60, A of 60. Let's do V of 60. Okay, V of 60 is equal to negative 0.159. And so our explanation is going to be he's speeding up. So Steven is speeding up at t is equal to 60 because velocity and acceleration are both negative. I'm going to put same sign. Another way that you can justify it is saying, hey, at 60, what's happening? Our function, our velocity is moving away from the x-axis. That's another way that some people do say that it is speeding up, but I recommend this way. It's a lot easier, it's a lot cleaner to say, and a lot cleaner to explain yourself on this AP test. All right, let's go do part C. Okay, so part C is saying, find the distance between Steven's position at t is equal to 20 seconds and his position at t is equal to 80. Show your setup for your calculations. Okay, so this one and the following one are kind of very similar. They're testing, do you know your difference between displacement and do you know your difference between total distance? Okay, so here they're asking for just plain old distance. You have to take that as displacement. You have to know, hey, they are talking about our displacement. And that is just, hey, your position at, in this case, 80 minus your position at 20. That's how what your gut brain's got to go to. And how do you do that? You just figure out, hey, what's our integral from 0 to from 20 to 80, right? That's just FTC part 2. So our real thing, how we're going to calculate this is go integral from 20 to 80 of our velocity function, and we're going to integrate that. So let's do that real fast. We're going to type int into our calculator. We're going to go from 20 to 80 of v of x dx. And we get that number of 23.383. Let's read the question again, make sure they're not asking for units. They are not. We are all good. All right, let's go to that last problem. Okay, find the total distance Steven swims over the interval from 0 to 90. Show your setup and your calculations. All right, so total distance is a little bit different. We're not looking for displacement. We're not just looking for integrating velocity. Okay, we have to do something else to this function. We are going to have to make v of x an absolute value. So what I'm going to do quickly is just graph absolute value of v of x to show you what this looks like. Okay, v of x, notice now changes that area to be all above the x-axis. That is what we want. Before, that area dropped down, and so when I integrated it, we had to subtract that area from the original, right? So so when we actually integrated, right, we took all of this positive area and then we had to subtract this because he was going backwards from it. However, we want to figure out the total distance. How far did he actually go? So what we want to do is make everything a positive area. Therefore, we're just adding all that distance that he went. So what we're going to do is we're going to integrate this new function, that absolute value v of x. So I'm going to do integral. Ooh, let me write that down. So integral from 0 to 90 of absolute value v of x dx. Because again, we only want to add the distance that he accumulated, not subtract the distance that he went back from. Kind of like with displacement. He goes forward and backwards. With displacement, you would subtract that portion that he went backwards. But we want absolute value. We want that total distance. We want to account for everything. That's why we need the absolute value. So we're going to have integral int from 0 to 90 in this case of absolute value is not there, drop down. Absolute value of v of x dx, because again, we want to account for everything, all of the accumulation that he did, not just the positive movement that he went. So that will be 62.164. All right, and there's no units there, none of that. That is his total distance that he has covered. He went forward and backwards, and using the absolute value function, we account for all of that distance. All right, so that is all those FRQs answered. It was pretty quick, very quick to be exact. All right, let's now talk about how the AP graders graded this FRQ. Okay, so again, each FRQ is worth 9 points, so they allocate the 9 points where they think the points deserve to be. And so let's talk about this. So for this first one, they gave every single student a point if they correctly thought about velocity sign. If you wrote down, hey, I'm thinking about something with velocity sign, they gave you 1 point. Specifically, if you set your velocity equal to 0, they're going to give you that first point. The second point was your answer. That 56 with your reasoning would give you that other point. So that first question is worth 2 points, one for just saying velocity is equal to 0, and another point for saying your time is equal to 56 and your reasoning. Problem number 2. This one was worth 3 points, surprisingly. The first point came from getting, hey, a of 60 is equal to negative 0.036. That gave you a point. You also needed that setup of saying, hey, v prime of t is equal to a of t. If you just threw the acceleration function there without describing how the velocity and acceleration are connected, they're not going to give you that point. They also gave you 1 point in this case because they specifically asked for your units. So if you gave your units, you would have gotten another point. And lastly, they would have gave you a point for your reasoning about Stephen speeding up. So all in all, that question was worth 3 points in total. Let's keep going. So for this one, for part C, they gave you a point for your integral if you correctly had your integral written and then you got another point for your answer. So 2 points just given there. And lastly, you got 1 point for your correct integral for total distance with the absolute value. And you got 1 point for your answer. All in all, this grading was pretty simple. Again, it was just really, can you use your calculator to find the things that they needed you to find? All right, that was all for the grading of this FRQ. And just like that, we have finished talking about this FRQ. This was, again, particle motion, and it only showed up on the AB portion for 2023. All in all, it was pretty simple, right? There's really just basic particle motion type of questions. There's nothing that was really tricky on this one. You just really had to know how to use your calculator. So I hope you found this video helpful, and I hope you're finding this whole series helpful, and I hope that you are studying really hard for your AP test that's coming up this year. All right, good luck studying, and I hope you catch my next video. Thank you for watching.